All right, welcome to the Explainer. Today, we are really going to pull back the curtain on artificial intelligence. We're going to deconstruct it down to its single most important building block, the intelligent agent.
We hear the term AI tossed around constantly, but what does it actually mean? How does a machine go from just, running code to making what looks like an intelligent decision? Let's dig in and see what's really going on under the hood.
So first, we just have to take a second to appreciate how completely AI has flooded our world. I mean, this isn't some sci-fi concept anymore, right? It's a tidal wave that is actively reshaping, well, everything.
You see headlines like this pop up pretty much every single day, and they paint this picture of a future that's, both incredibly exciting and maybe a little unnerving. But look, whether you're an optimist or a pessimist, everybody seems to agree on one thing. This future is getting here a whole lot faster than anyone thought.
And this isn't just hype. I mean, AI is having a real-world impact as we speak. We're seeing these huge tech deals, major shifts in how politics and business get done, and even new cultural battlegrounds opening up over things like art and copyright. Okay, so if you're going to build an intelligent machine, it really helps to have a blueprint. And the best blueprint we've got is our own natural intelligence. So let's start right there.
I'm willing to bet your brain had absolutely no problem reading that, even with all the jumbled letters. That's because our minds are incredible. They can take in messy, incomplete data and just instantly figure out the real meaning. This ability to find the signal in the noise, that's a core feature of intelligence.
And this brings us to a really crucial point. See, intelligence isn't just about storing facts like a computer. It's this active, dynamic loop of perceiving the world, learning from what you see, and then using that knowledge to adapt and solve problems.
And check this out. This really shows the fundamental difference. When we see a picture of, let's say, Cristiano Ronaldo, our brain instantly links it to this huge web of context: soccer, his teams, rivalries, pop culture. And AI gets to the same answer, Ronaldo, but it does it through a completely different, purely mathematical process of just analyzing pixels and matching patterns. Two very, very different roads to the same destination.
So, keeping that difference in mind, let's drill down to the one foundational idea that holds up pretty much all of modern AI. If you can forget about all the complicated algorithms for just a second, it all comes down to this one simple, powerful concept: the agent.
Now, I know that sounds super technical, but it's actually incredibly simple. An agent is just a doer. That's it. It senses something about its world, and then it does something in response. A thermostat? That's a simple agent. A self-driving car? That's a very complex agent. But they're both agents.
And every single agent, from the dumbest to the smartest, runs on this basic loop. It uses its sensors, a camera, a microphone, whatever, to get data. It interprets that data into something useful, called a percept. Based on that, its program decides on an action. And then finally, its actuators, the wheels or the motors or the speakers, carry out that action. Sense, think, act, over and over and over again.
So, to make this really concrete, we can use what's called the PEAS framework to map out any agent's job. So for a robot taxi, its performance goal is a safe, fast, profitable trip. The environment is the messy world of roads and traffic. The actuators are the steering wheel, the brake, the accelerator, and the sensors are its cameras and GPS, its eyes and ears on the world.
But obviously, a thermostat is nowhere near as smart as a self-driving car. And that's because agents have evolved. They started out as these really simple rule followers and have slowly become much, much more sophisticated thinkers. So at the most basic level, you've got the simple reflex agent. This thing has zero memory. It only reacts to what is happening right this second. It's pure stimulus response. If the car in front slams on its brakes, it slams on its brakes. That's it.
The next level up is a huge leap because we add memory. A model-based agent keeps an internal map of the world in its head. It understands that just because a car drove behind a big truck, that car still exists, even if its cameras can't see it right now. This ability to track things it can't directly see, that makes for way smarter decisions.
Okay, now this is where it starts to feel like real intelligence. A goal-based agent doesn't just react, it actually plans. You give it a goal, like get me to the airport, and it starts thinking ahead, considering all the different routes and all the possible turns to find a path that actually gets it to where it needs to go.
And then at the very top, you have utility-based agents. These guys don't just want to achieve a goal, they want to achieve it in the best possible way.
They weigh different outcomes. Is this route faster? Is it safer? Will it use less gas? And they choose the path that maximizes their utility or their overall chance of success.
So, what happens when you combine all these steps? When you have memory and goals and this idea of utility? Well, you arrive at the absolute frontier of AI today, a concept that's exploding called Agentic AI. This is where all that theory becomes a wild new reality.
And trust me, this is not just some academic idea anymore. The power to build these sophisticated, goal-driven agents, that is the paradigm shift happening in the industry right now. It's the holy grail that all the big AI labs are in a flat-out race to perfect.
This slide really gets to the core of what's changing. Think about a simple chatbot versus an agent. A chatbot answers your question, and then it's done. It waits. But you give an agent a goal, and it will work on its own, step by step by step, until that goal is finished. It's the huge difference between a passive tool and an active problem solver. Here's what that looks like in action. You don't tell it, write an essay paragraph by paragraph. No, you just give it the goal, and it figures out the rest. It plans the outline. It uses a web browser to go do research. It writes a first draft. And then, and this is the crazy part, it looks at its own work, reflects on it, and revises it to make it better.
And the reason this is all possible now is because three key things have come together. You have the large language model as the reasoning brain. You have tools, like a web browser or a code interpreter, that act as its hands to interact with the digital world. And you have memory, so it can keep track of what it's doing and learn as it goes.
So now that we have this framework, this idea of the agent, we can look at all the wild headlines and the hype around AI with a much clearer, much more grounded perspective.
And this, of course, brings us back to the biggest question of all. When you're building agents that can perceive and reason and plan and learn all on their own to achieve whatever goals you give them, well, the question of whether they'll eventually surpass our own intelligence, that stops being science fiction. It becomes the defining technological and maybe even philosophical challenge we have to start answering right now.